This is problem 3.1. A weight of 50 Newton is suspended from a spring of stiffness 4000 Newton per meter and is subjected to a harmonic force of amplitude 60 Newton and frequency 6 Hz. The first question asks you to find the extension of the spring due to suspended weight. So remember, if the question asks you to find extension, it means deflection. Okay, next the question asks you to find the static displacement of the spring due to maximum applied force. Also deflection. Static deflection lah basically. Okay, and lastly for C, the question asks you to find the amplitude of forced motion of the weight. Okay, the question asks you to find the X. So now, the first step would be A. Find the extension deflection, right? Due to the suspended weight. So over here, deflection equals to force divided by the stiffness, right? So the force that we can use for question A is due to suspended weight. We can use the weight, okay, because weight is a force, okay, both is Newton, right? So weight over stiffness, where your weight now is 50 Newton and your stiffness is 4000. So your deflection will be 0.0125 meter. Okay, we've already got the answer for A. Now moving on to B. Okay, the question asks to find the static deflection. Remember, in order for you to find static deflection, you can use the formula of del St equals to harmonic force divided by the spring. Okay, you can find this in your lecture slide number 6. Okay, if you take a look at your lecture slide number 6, you can see that over here, del St equals to F0 over K. So static deflection equals to harmonic force divided by the stiffness. This is the formula that you can use. Alright, so we've already have the harmonic force or the maximum applied force to be 60 Newton. And your stiffness to be 4000. So from here, we've already get the static deflection to be 0.015 meter. And that's the answer for B. Now let's try and find for C. For C, alright, the question asks you to find the amplitude. So the one that we can use also from lecture 6. Okay, so we can use this formula over here. Alright, we can use this formula over here, where x over static deflection equals to 1 over 1 minus omega over omega n square, which also comes from here actually, this formula here, where we know that F0 over K is static deflection. So they just bring static deflection to the left side over by the x, becomes this, that's all. So we can also use this formula, depends on what you are going to do. Alright, but the question asks you to find the x, so we can find the x using this formula. So we know if you want to use that formula, we've already have the static deflection, we already have the static deflection, but we still don't have the omega and omega n. So first we find omega n, and in order for us to find omega n, we have to find the mass first. So the first step is to find the mass. Mass equals to weight over gravity. which your weight is 50 divided by the gravity 9.81, and your mass is 5.0968 kilogram. The next step is to find your omega n, which equals to Z K over M. Your stiffness is 4000 and your mass is 5.0968. Which you get your omega n to be 28.0143 radian per second. The third step is to find your omega, your force frequency, which you can find using the formula 2 pi f. 2 times pi times your f is 6 hertz. So calculate this and you'll get 37.6991 radian per second. And the fourth step will be is you use the formula just now, alright, where the formula is x equals to static deflection over 1 minus omega over omega n square. Okay, we've already have all the values for this equation, so substitute all of them. Okay, your static deflection is 0.015. Your omega is 37.6991 over omega n is 28.0143 squared. So then calculate this, okay, in the end you'll get negative, but remember for amplitude will never be negative, so we can put the modulus sign over here to show the amplitude will never be negative, and if you get your answer to be negative straight away, make it positive. So in the end, you'll get your x to be 0.0185 meter. That is how you solve for problem 3.1. That is all.